Hello, listeners. I'm really happy to be sitting down with Simone Sidoli for our Immagina podcast, where we learn more about the research scientists are doing in the ribosomal translational field. Simone, could you please introduce yourself and the work that you're doing at the moment?
Yes, thank you, Elisa. Thank you for the invitation. My name is Simone Sidoli. I lead now the Sidoli lab at the Albert Einstein College of Medicine in New York. I'm currently an assistant professor, and we have a proteomic lab where we investigate anomalous DNA unfolding in different conditions, like including cancer, aging, and infection.
With the research that you're doing now, what do you hope to accomplish, or what is the best result that can happen?
Yeah, so our goal, the reason because we study DNA decondensation is because we investigate the new dimension of genomic instability, which is basically the effect of spurious RNA transcription when DNA unfolds. And we want to identify what kind of RNA is being produced during these decondensation events, what kind of proteins bind to these decondensed domains. And basically, our ultimate goal is to identify targets which can be used to potentially treat or minimize or say delay phenomena like aberrant chromatin decondensation. And there would be very specific targets because there would be proteins that are only active when chromatin has this type of issues.
And with the research that you're doing in the lab, how does the de novo protein synthesis impact it specifically?
Yeah, this is really good question because it's a critical aspect. So when we have, for example, like some virus infection, it's normally most proteins do not change their global level. What really changes are specific synthesis of specific proteins that, for example, they can be triggered for multiple reasons. Part of it maybe because they are left hijacked by the virus or because of this chromatin decondensation event. So what we really need to do, we really need to know in our systems when it gets perturbed, what kind of proteins are being synthesized at the moment. I like to use this example of the typical household. So when you get into a house and you look at the common stuff like the couch, the TV, the bedroom, usually this doesn't really tell you much about what is going on in that home. But if you start looking at what is cooking on the stove, if you start looking at what is present in the garbage bin, that tells you if that day there was a special event. And that's why we need this sensitive, rapid synthesis of protein, because we know that the global protein level is going to be similar in our conditions. We want to know which proteins are being produced in that moment.
And can you describe a little bit about how Immagina Biotech can help your science going forward?
It has been very helpful already. So we use the kits of Immagina. They've been extremely helpful for us to identify which proteins are being synthesized at the moment in our biological model, where we model aberrant chromatin decondensation. Is actually this is only the first step. We want to use them also for RNA. Because we also suspect that some of these RNAs that are being produced during the decondensation of the DNA are probably going to be also non-coding RNAs, and we still think that they might get recruited by ribosomes. So honestly, the kit from Immagina is the best tool available now to enrich for these biomolecules and identify them. So yeah, we're really happy to work with Immagina, and we also have great assistance whenever we have all of our questions. So it's great to work with you. If it wasn't clear.
We're very happy that you're happy then. Those were all the questions for the podcast. I'd like to thank you for the time that you spent on this, and thank you again for all the compliments.